Hi. I think this episode will be the last episode before Christmas. So I wish you all a happy Christmas, and I wish peace for the world for the next year. I know a lot of conflicts exist in the world, but I hope that every country to get peace and people get prosperous, and yeah, uh, get enjoy their life basically. Anyway, today I'm really eager to introduce you a new product which is very essential for laser calibration. So you know that in 3D or additive manufacturing, there are different methods to use laser. So all of these machines or methods basically somehow use light or laser. And now I would like first to a little bit talk about these three different methods in additive manufacturing to somehow turn one type of material or one form of material to another form to shape these structures. And but this is not the main issue. The main issue is to introduce a new product that is useful to calibrate this laser system inside the 3D additive manufacturing machines. But let's briefly talk about these methods in 3D additive manufacturing. The first one is called basically okay, I will start from this one. This LPBS, which I think it's a kind of like gantry based laser powder bed. So in a way that the powder using kind of laser will be turned to in fact in a structure. This is a very nice video from Fraunhofer. Let's see with each other. So you see there is a tool and this tool is connected to a maybe 5 axis based system which or maybe Cartesian based system. But the main idea is that this laser would turn the material from powder to solid. So as you see during the process, very complicated structures can be built. And this is one example of, in fact, LBPS, I think, from Fraunhofer. This was one way to use laser method. The another way which is useful to use light system is stereolithography, which unlike laser that turns powder to solid, this structure or this method use light, different ways, wavelengths of light, but it depends on the material or base material. But the base material is basically liquid, and you can create basically polymer out of this liquid using light. So this is a very also short, interesting by Materialize company using a stereolithography, and this is also a very cool machine that turns liquid, in fact, into very strange, I would say, structures. And it's basically works like that, that a solid forms comes out of liquid using the lights. And so this is kind of lithography. This is the third way or third method to be used in additive manufacturing. So all of them, as you see, this light system, the focus, everything needs to be precise to create a precise structure. The third method is called SLS or laser sintering. What's the difference? I think I also found a very interesting if I don't know, so maybe this one is also again, you have powder. You put usually 1 millimeter powder, but the difference between this one with LBPS is that this one usually turns powder. That one turns powder to metal, but this one turns powder to different type of polymers like ABS or PS or whatever. So the base bed plate is filled with there's a heater, and then you have the beam of the light to be focused using mirrors, and yeah, the orientation, positioning, everything is controlled by this mirror in the system. And then using this light, you can basically layer by layer turn the material to basically from the powder to plastic. So this is a kind of competitor to injection molding that comes out the plastics, but this one is making complicated structures just by layer adding or adding layers. And at the end, these extra things should be go away. The top material or the main material comes out. All right. So this was just a short introduction of what is the methods that is used in 3D additive manufacturing. But now I don't want to talk about that. I would like to say that there's a company so-called Laser. I think they are based in Germany. I'm not sure, but they, every laser machine or any additive machine needs to be calibrated. So basically, we suppose that the laser that is actually building these layers by layers is precise enough. And sometimes we need a really precise object, right? Or a structure. So, but to be assured that we need somehow a grid, a plate that is called calibration field or calibration grid to assure that the machine is calibrated, is the laser beam or whatever the head that is inside this machine is calibrated to produce a well calibrated object, right? So we use some kind of plate, scan field plates. It's like a grid, and it goes inside this machine. And as you see, as you know, let's review this together. I will explain. Maybe it's better. So these are the machines that I was talking about. So each laser machine needs some kind of a plate or calibration plate. So as you see, the laser goes and points these grids inside, and in a manual world you need a ruler and a field or a text file to say that, okay, these dots from each other, how much failure or difference has as it should be. So you write them in a table, and then you say that, okay, I know the differences and I can correct these differences in the machine. This is a manual work. But laser SFC 600 Ray Lace has produced this very cool scanner that instead of manually calibrating or measuring this and finding the error, it goes like a scanner. You can put this scan field or grid line or grid field on that, and that it can visually and very effectively measure these dots and produce the SFC data file for you, and then it can automatically be uploaded to the machine, right? And this calibration can happen, and the error can be reduced, or they claim that to 15 plus minus 15 micrometer, which is very accurate, I would say. So they can achieve to that tolerance to optimize the position. So I think the biggest, I'm not sure, but the biggest form is 60 centimeter and 60 centimeter, the plate, I mean. Uh, and it can be used for visualization, for camera calibration, and also for laser itself. So they put it in this. It's really doesn't matter how fit you really put it. It can detect the orientation as well, and it can detect these lines that the laser was created on the plate, and automatically all this information can be transferred to the computer and to be recorded in an XML file, or I don't know, maybe SFC file, or very like a Office file that can be later used for calibrating the others. So this was the product that I would like, I wanted actually to introduce, and I think it's very handy for, especially if you are in additive manufacturing, and I think that you like to just maybe give it a try, or yeah, contact with the manufacturer. All right. I hope that you enjoyed this episode, and we will see each other next time. Bye.